Dear students, so here electricity lesson. In this lesson, in the last session, we learnt about the resistors. How there is which factors are there, they depend on for the resistance, and also about the resistors in a series. About that we learnt in the last period or in last session. So now in this session, we are learning about the resistor in a parallel. As the resistor, any conductor is there, devices are there, or any component which we are using in our home. For every device, component, conductor, it has some resistance is present. So resistance may be this resistance that is nothing but it is also the devices like you are using in our home. There are the refrigerator is there, washing machine is there, iron is there. So there are the different devices which in our home we are using. And we saw yesterday here in the series connection, whenever we are giving a series connection or resistors, when we are joining in the series, that time there is current is the same flowing, current flowing through that resistors is the same, it is not changing, and here there is a change in the potential differences. So here potential differences are there, means if 240 voltage we are giving, now the current which will come in our home, it is always 240 voltage it is there. So that 240 voltage, it is a dividing as per their capacity, means it is sometimes inbuilt is there in that resistances. So like that here if there is the 40 voltage is there you are giving here, that 40 is a dividing like 25 and 5. So sorry, 20, 15 and 5. Like this it is dividing. So that is nothing but the V1, V2 and V3. So the voltage is there, the potential difference is there, it is showing by R1, R2 and R3. It is also, it is different one we are observing, but current is there flowing in that, it is a same one. So that is the series connection is there. Now we are going to learn in a parallel, when resistors are joining here parallel to each other. Now R1, R2, R3 are the resistors here we used, and here is the diagrammatic representation. By that we are going to see, we are going to check that here potential difference and also the current how it is flowing in the parallel resistance. Here R1, R2, R3 is joining and we are individually also going to check their potential difference and also we are going to check a common potential difference. Here how we checked yesterday individual potential difference and total. So V is equals to, as in the series, V is equals to V1 plus V2 plus V3, that is if 40 is there, means 20 plus means its capacity. I divided that one, not always 20, 15, 5. I gave one example that 40 is there dividing in that. So here that is the V is equal to V1 plus V2 plus V3 is there, and we saw yesterday equations and by that here series connection is there, by that we got here RS is equals to R1 plus R2 plus R3 is there. Now here for the parallel connection, when we will join the resistors in the parallel, in that there is the same diagrammatic representation is there, only the resistors we are joining in the parallel connection, as there is a close and open key is there and ammeter is there, battery and current is flowing through the circuit of that. So here devices or resistors are there, they are joining in the parallel one. Here it is observed that the total current I is equal to sum of the separate currents through each branch of the combination. When there is a current is flowing in that time it is observed that total current I is equals to, here I how much it will come, it is equals to the I1 plus I2 plus I3, means it is a dividing here. So current is not showing here same flowing in all the circuit. Here we saw in the series connection current is the same, it is flowing in each resistor, but here in the each resistor different current, but I is equals to I1 plus I2 plus RT. So here total current I is there, it is equals to the equal to sum of the separate current through each branch of the combination. Through each branch of the combination that current is flowing and it is dividing there. So it is nothing but I1 plus I2 plus I3 it is there. It is a different one, it is a dividing, not it is the same for the each. Means here also if we are going to take I is there like here 2 ampere, 3 ampere and 0.5 ampere like this, and that is I is equals to 2 plus 1 ampere like a 5. If 5 is there, 2 plus 2 plus 1 like this it is there, means it is a separate different one for the different resistors. I am giving you an example, that is the if 5 ampere current is flowing, current is the 5 ampere, then there is it is a I1 2, I2 2, I3 1. So like this that is dividing, and that is nothing but I1 plus I2 plus I3. So the total current is equals to, it is the sum of the separate currents through each branch of the combination, from each branch of the combination. When we are here adding that one all, that is total of the I1 plus I2 plus I3 we are getting here. Let Rp equivalent, it is nothing but the equivalent resistance of a parallel combination. So here Rp is there, we are taking as a for the RS. Yesterday we saw RS. RS means when the resistors are in the series connection. Rp is the resistors are there in the parallel connection. So Rp equivalent resistance to the parallel combination of a resistors. By applying Ohm's law here, parallel combination of resistors as Ohm's law, V is equals to IR. Then now I is equals to V divided by Rp. So here here outside take means I is equals to V divided by, when E is equal to sign is there, that side it is going means V by R. R means now here Rp resistors in the parallel. How yesterday we saw resistor in the series, like that resistor in the parallel. So I1 is equals to V divided by R1, I2 is equals to V divided by R2, and I3 is, as it is value of I is there, as I you know that is a I1, I2 and I3, it is a different one current flowing through each, and V is there, it is a common potential difference here, not changing, it is a same only. So here potential difference is there, it is not dividing here, so V is equal, V is as it is, we are going to keep that one. Resistance are there for each device or component, it has a different resistance are there. So it is inbuilt resistances are there, capacity is there available in that devices, that is R1, R2 and R3. So I1 is equals to V divided by R1, I2 is equals to V divided by R2 and I3 is equals to V divided by R3. From equation 1 and 2, when we will add that one, we are getting that there is V is 1, 2 and 3, sorry 1, 2 and 3, when we will get there is V divided by Rp. So here V means as you know V divided by Rp, that is I1. I1 is equals to V divided by R1. So V is equals to V divided by Rp. V is the common one, that is I is equals to I means current. So V divided by Rp is equals to V divided by R1 plus V divided by R2 plus V divided by R3. So on applying Ohm's law to each resistor, when we will apply the Ohm's law there for the each resistors, as I is equals to V divided by Rp. So here we are taking instead of I, that is V divided by Rp, and see here this and this, when we will comparing, you are going to understand Ohm's law is there, this one, that is I is equals to V divided by Rp. I value how much it is there, V divided by Rp. So keep that value V divided by Rp there. So next one here I1, how much I1 is there, that is nothing but V divided by R1. Next I2 value here put out, that is the all the values are there, you are inserting. When we are combining equation 1, 2, 3, you are going to understand that is Ohm's law, and I is equals to V divided by Rp. First of all resistors in the parallel, for that, and so I, the total current is there. So for that V divided by Rp, insert that value. Then I1 value V divided by R1. Then I2 value V divided by R2. Next I3 value you should insert there, that is the V divided by R3. So V divided by Rp is equals to V divided by R1 plus V divided by R2 plus V divided by R3, as it is a reciprocal. So here voltage is there, that is a common one. So as yesterday we saw, I is there, current flowing through the series is there, it is a common one. So here instead of V we have to write there 1 divided by Rp is equals to 1 divided by R1 plus R2 plus R3. So that is the reciprocals are there. Thus, we may conclude that the reciprocal of the equivalent resistance, that is of a group of a resistance joined in a parallel is equal to the sum of the reciprocals of the individual resistance. So, how yesterday Rs is equals to R1 plus R2 plus R3 we got, that is here reciprocal is there, it is of a equivalent resistance is a group of a reciprocal here resistances joined in the parallel connection, when that time that in a parallel is equal to the sum of the here reciprocals of the individual resistance. It is nothing but the reciprocal of the parallel is equals to the reciprocal of the individual resistance is there, that we are getting the equation here. So here this is the resistor in the parallel, for that we are getting the equation here, and we are going to calculate that is reciprocal resistors in the parallel. For that purpose there it is the formula we are getting, and how there is a resistors in a series and parallel, how they are connecting, and how here current is flowing in the series, it is the same one here, current flowing in the parallel series is there, it is a different one, it is nothing but the total current is the it is nothing but total current is equal to the combination of the I1, I2 and I3, that is a flowing a different one current, means it is equal to sum of the separate current through each resistor, or here through each series parallel combination in each resistor it is flowing. And here we are getting a potential difference is a different one, here potential difference is same one. So that both are the differences, and it is nothing but reciprocal of a parallel resistor is equal to the sum of the here resistors in a combination individual resistors are there, that is the total or sum of the here individual resistance we are getting here. So this is about the resistor in a series and the parallel. Now as you know here, when we are joining a refrigerator, iron and also washing machine or any mixture grinder, here there what will happen, there is a current capacity is there for each one, it is a different one, but here what will happen, it is a current flowing is the same one. So we need a different one capacity for each devices. So here means here whenever this joining all the series combination, when there is a 240 voltage will come in our home, and that 240 voltage is there, it is a dividing, but the current flowing is there same in each resistor or in each device. So we need a different one, and it is the disadvantage of the series. And so when series connection is there, means here refrigerator, washing machine or bulb or any other television is there joined in a series connection. If any one is there not working, it will stop its working, or current something will stop from that because of the damage, then current is not flowing to the next devices, they all also not working, means everyone is there, system is there stopped when we are using a series connection. So for home purposes series connection is not using. In the stations where stations, electricity stations are there available, in that for transportation purpose they are using the series, but here parallel connection is there in our home, we are using as current is also dividing here, voltage is the same supplying, and how much it is necessary for the devices, it is dividing there, and that devices are there, that is using that, because everyone has a not same capacity, as the refrigerator is there, washing machine, its capacity is a more one, and so because of that it has a here parallelly, means current is flowing, now how much current they need for each, it will take it properly, and it is dividing there. So we have seen that in series circuit the current is a constant throughout the electric circuit. So current is a constant one throughout the electric circuit. How many devices you are joining in our home, that all are there, that for that all same current is flowing. Thus here it is obviously impracticable to connect an electric bulb and electric heater in a series. So here it is not good one, it is impracticable, as we are joining a heater and bulb. A heater need a more voltage and current, and so here, but if bulb is there, it needs a less one. So because they need the current of a widely different values, as current is flowing same here, but what we need here, current for the heater is more it needed, but current for the bulb it less needed. But current flowing in the here in each resistor or in each device it is same. If heater is there and also there is a bulb need not here not need that much current flow from that, and so here it is not. So because of that they need the current widely different value to operate properly. Another major that is one of the disadvantage of that, and again one disadvantage is there here, that is the series circuit is that when one component fails, the circuit is broken, none of the component work. As I told before also, when any one in the series circuit, when one of the component, one of the device is not working properly, means or fail, then here other components also not working, because they are connected to each other in the series one. If you have a pairing circuit is broken, and you know that lightning lamps are there in festivals we are using, broken and none of the components works. So if you have fairy lights to decorate building on festivals, on marriage celebration, you might have seen the electrician spending lot of time trouble locating at replacing a dead bulb, because there is a lightning bulbs are there, they are in a series, they are joined, and if any one bulb is not glowing, that is a circuit is broken down. So current is not going to the next one resistor or next one bulb, and so because of that here electrician is there, he is spending more time to find out where is a circuit broken down or failed. So here there is a trouble on locating, replacing the dead bulb. Each has to be tested to find has fused or replacing the dead bulb here. So or gone or whatever the bulb gone, otherwise here there is a fuse one is there. So it is necessary to check out, and then the next bulbs are there, they are also glowing when it is repairing the damaged one. On the other hand, there is a parallel circuit divides the current through the electrical gadgets. As I told, parallel is there, in that current is dividing there. As electrical gadgets means electrical devices, components which we are using, how much they need current, that much it is here present, or it is dividing, and it will take. The total resistance in a parallel circuit is decreased as per here equation 12.18, as we saw total resistance in the parallel circuit is there, it is decreased. This is helpful particularly when each gadget has a different resistance. Each gadget has a different resistance and requires a different current to operate properly. It needs a different current, and so when we are joining a parallel connection and when we are giving a parallel combination, each resistor is getting a different one current, and so here it is good for the working. And as we saw, if any one is there here failed or broken, or any fuse is there gone, then if it is not working R1, then R2 and R3 is working independently. But here what will happen, if R1 not working, R2 and R3 is not working here, means here it is depend on each other. These are independently working. Whatever the other resistor is there, if they are not working or fell down, or there is a fail of that work, current is not flowing from that, or broken down the circuit, if it is taking place independently, they are going to do that work in the parallel connection. So here this is about the resistors in the parallel and the series. And also these are the equations are there, in that some problems are there. You should try out the problems also to solve there. Thank you.